I made this up to help you understand. This is your main rotor, your 4 poles for like an 1800 RPM generator. This would be your main windings, which would be your house power. And this is the external part of your brushless exciter that the field, that the voltage regulator manages. Each one of these little black discs represent your diodes on your coils. When you're trying to diagnose what's happening with your output, there is no way to get a voltmeter on any of this while it's turning to see what's happening. So you have to understand what's taking place inside there. When this starts rotating, the steel core in the main rotor holds a little residual magnetism. And you can see that by holding the compass up. There you got the red needle pointed to it. There you got the white needle pointed to it. That represents south, this represents north. If you don't have that, you have nothing to get the process started. As soon as the magnetic field starts to enter, what happens is it starts putting voltage out and it goes down to your AVR. As soon as the AVR sees more than like 5, 6 volts, it turns on and starts feeding power into these coils, which as they intersect with the rotating coils, it starts making power. What's generated in these coils is your AC that goes into the diodes and ends up being DC, and it gets fed back into the field. Once this starts feeding the magnetism that was already here, it starts to grow, and it brings it up to the potential voltage for your load. The AVR then, it just controls the level of the voltage so that this stays at 240 or whatever your load is. The interesting part is when this is not performing right, you don't know what's breaking down in here without starting to test them. Like, you can go and you can test the diodes and start dissecting it. You can test your windings with like a megger to see if they're shorted or grounded. You also have the leads going into the main part of the rotor. This is your exciter, but it has 2 wires running into the main part of the rotor. Before they started using the brushless exciter to feed the main rotor, they actually put a slip ring on the back and they'd use a set of brushes. Then your voltage regulator fed through the brushes and right into the main coil. The problem is if your brushes are arcing, you get fluctuation in your field, and it's just, you have wear, you'll have corrosion get on these things, and if they're not clean, it won't build voltage. So by going to the brushless exciter, now we have no physical connection from the outside to this. This is a self-contained unit, no brushes or slip rings. You'll notice that the main rotor, the coils are wound opposite. This one's wound opposite of this one. So you got a north-south, north-south. That's standard on any 4-pole setup. When you're dealing with your exciter, it's the same way. These are wound opposite of each other. You have a north and a south. Because if you don't have opposite polarities, you won't get the AC volts out of it. An example of that is, when you put a battery on the stationary part of the exciter, you can put your compass inside there. There you got white. Hold that up so you can see. It'll transition to red, white, north, south, the whole way around. As the coils of the rotating part are passing each one of these, that's where your AC voltage is produced. Once it starts putting out AC power, this is another one I have laid out here so you can see. When you start producing AC power, it comes on these leads into the diode bridge. and the diode bridge turns it from AC power back into DC, and that's how it gets fed into the main part of the rotor. So instead of having a slip ring on here to feed it, you can put this guy right on the back there, and you can feed this directly into the main part of the rotor. This gives you a little illustration when you're putting on a voltage regulator, your lines from your gen end feed into the regulator. Actually, the regulator diode assembly in there turns us into DC power, and that's where you get your field. I have a real big one there. I think that's some for Onan set. Basically, your bridge rectifier looks like that. You got 3 diodes on either side, and they're this set is opposite of this set, the cathode and the anode. When you have the AC power being produced, you got your AC above the line, or your positive above the line and the negative below the line. Those diodes are sending it to its designated polarity. That's how you get your DC. If you're working with a permanent magnet generator, this here would be in addition, like on the back side of this. All the permanent magnet generator does is you'll have the sensing voltage coming into the regulator, but it will not use the line to feed these coils. What actually happens is they only use the line for sensing, and you'll feed 2 or 3 more wires additional into the voltage regulator, and the power that's being made by the permanent magnet, you can see this rotor has got a permanent magnet inside there. All this does is provides the power to feed these coils. The purpose of that is, let's say you have a large facility and you got 5 different wings, and each wing has a 200 amp breaker. If something went wrong and the one facility is in flames and that 200 amp circuit gets shorted, when you have a dead short on these windings, if it can't build any residual, the regulator can't turn on. So what you actually have is the generator turning, but the short across these lines is so great, you don't get enough voltage for the regulator to turn on, and it never starts producing power. If you're using a PMG, it's looking at the line power, and it says, I don't have none, but I have voltage to work with. So it starts feeding full voltage into these fields, and it'll start smoking the main rotor. That actually happened on a facility where we smoked a portion of the rotor because it works as hard as it can. If you, like I said, if you have one facility and one 200 amp circuit is completely shorted, that breaker will open because this can produce enough power to heat the breaker up enough to trip it open. But if you didn't have a PMG, there's a possibility this will never start producing power, so all of the building will be completely dead. They call that fault clearing. So anytime you work in emergency, like emergency rooms, anything that's life safety, life critical, they require you to put the PMG on for that very purpose. Because, you know, if the whole hospital's going up in smoke and the operating room's still okay, they want the lights on in the operating room. You know?
I can appreciate that.
I noticed when I was playing with this compass, if you have a rotor that drags like this one did, the first thing that happens is it wipes the residual out of the steel. I held this compass up and it points to the steel only because of the magnetic part of the metal. There's no residual. I can't get a south pole out of this because the residual has been gone. If I would take this and power up the field, you'd actually start to establish that magnetic field again. If somebody tells you that they had to put a battery on their field and get the thing to start producing, and then they tried to use the generator later and they didn't get anything out of it again, most likely they never put enough load on it for a long enough time. The more load you put on the generator, the more, the stronger the magnetic field inside these poles is. So if you can take it to half load, full load, and do that for a period of time, you're driving the magnetism back in the field. It's just like some guys will take a screwdriver and they'll put a permanent magnet against the screwdriver and they'll lay it in their toolbox. And that keeps this thing magnetized so you can use it to pick up screws. That's the same thing that you need to do with a generator, is when you use it, it has to build that magnetism in. One place that you can lose your magnetism, you take a PTO, if you drive it down a bumpy field lane, you have enough flex in the shaft that as that rotor is bouncing up and down, you're getting closer and further away from the coils. Anytime you're making some type of transition with the coil, you're producing some kind of power. If you're producing power, you're erasing the magnetism. So since you're driving down a field lane and that thing's not doing anything, you're making some power. You're outputting a little bit. It would be minute, but it's erasing the magnetism, and then when you go to start it, you've got nothing to get going. On a lot of these, if you look inside, in on the main part of the field, they'll have a permanent magnet embedded into it. That permanent magnet will affect this and start to build a little bit of voltage, and that'll get the thing going. That's just kind of a surefire way of making sure that the thing comes up to potential. When I was winding this thing, I did it for illustration purposes. I was thinking about the 4-pole generator versus the 2-pole. And I started looking at some diagrams. When we do a 12-lead generator and we want to make 480 volts or 208 volts, we switch the leads around. Like if you take and series your coils, you end up at 480, but if you parallel them, you got 240. If you're running a 3600 RPM generator, on a 4-pole, you got north and south, top and bottom. You got north, top and bottom, south on either side. And as that thing rotates, you actually have 2 sets of north, 2 sets of south. On these field, on the main winding, your poles are touching top and bottom, and you'll take this coil and parallel it with this coil and you'll get 240, or you'll series these two and you'll get 480. But if you're running a 2-pole, you'll never be able to get a 480 volt out of it because your poles are at the wrong place. You can't use this one if it's being affected by a south, and that one if it's being affected by a north. It's not something you're going to work with that much, but if you understand the principle of what's taking place. Dave and I were having a discussion on a unit that when it was running, the RPM was steady, and it would go from 60 and up. The hertz would go up and down, up and down, up and down, and we'd get an overspeed. And we were trying to figure out what was happening, and we think we got it. The only thing that I could determine, since I couldn't measure anything while it's running, there had to be something wrong with the diodes. If your generator is turning the same speed all the time, you're not going to add any pulses because the pulses are determined by the north-south, north-south. Unless one of those diodes has a short or an open, like if it's arcing internally. If the power coming in has the ability to pulse, and this field can build and collapse because of arcing that's taking place, that's the only way I can see possible that you would get additional frequency out these lines when there's no load attached and it's spinning at a constant speed. We went and put diodes in and it hasn't done it since, so hopefully that's what took care of the problem. But that's why it makes it so difficult when you're working with these brushless exciters. There is no way for me to actually put a meter on this and see why it's doing what it's doing. Is anybody working with something